Piecewise defined functions look like this, where we have y defined in different ways depending on what part of the domain we're working with. Like, for instance, in this one, y is minus x minus 2 if x is less than or equal to negative 2. So we would define y by finding the opposite of x and subtracting 2 from it for values of x that are less than or equal to negative 2. If x is between minus 2 and 1, and notice we're not including minus 2 or 1 here because minus 2 is included here and 1 is included here. But if x is between minus 2 and 1, then we would find y by squaring x. Y is equal to minus x plus 2 if x is greater than or equal to 1. So if x is greater than or equal to 1, then we would find y by finding the opposite of x and adding 2 to it. So let's just take this first part here, the part where if x was less than or equal to negative 2, then y would be found by finding the opposite of x and subtracting 2 from that. So we can make ourselves an xy table like we normally do. And what we'll do here is specify that for values of x that are less than or equal to negative 2, what we'll do to find y is find the opposite of x and then subtract 2 from it. So for instance, if x is minus 3, which is less than negative 2, then we would go minus 3 minus 2, and we wind up with 1. If x is minus 2, and we have less than or equal to minus 2 here, then y would be 0. The opposite of negative 2 is 2, minus 2 is 0. And here's what that part of the graph would look like then. So if x is less than or equal to minus 2, so that's values that are to the left of where x is negative 2, less than or equal to negative 2, then we have this linear graph here. This linear graph that would continue on forever then in this direction. But that's not the only thing that we have in this function. This function also has another part where if x is between minus 2 and 1, then we would square the x values. And so let's put some values that are between minus 2 and 1 in for x. The table, this xy table that we have constructed here is similar to what we had before. If x is less, or if x is negative 1, then y is going to be 1 because we'll square that. If x is 0, then y will be 0 because we'll square that. And so now these two parts of the piecewise defined function here we have graphs for. So between where x is negative 2 and 1, so that's going to be from this area here between where x is minus 2 and 1. The dots that we've graphed are these two, minus 1, 1, and 0, 0. And we know what x squared looks like. X squared is a parabola, so it's going to have this shape to it. Now there's some gap in between here that we'll talk about a little bit later. So now if we bring in this third part of this piecewise defined function, that was for where x was greater than or equal to 1. And when x is greater than or equal to 1, y is defined as minus x plus 2. So again, we'll take some x values that fall inside that range where x is greater than or equal to 1. So like, for instance, 1 and 2. And the corresponding y values then will be 1 when x is 1 and 0 when x is 2. Just plugging into the function here. And then here's this piece of that graph, and this would continue on forever like this. Now, if we were to put all three of these pieces together, we would have this now. So our piecewise defined function graphed on one set of axes would look like this. And again, in between where x is minus 2 and x is minus 1, and another gap between where x is 0 and x is 1. So we got to do something about that gap. Well, we realize that all of that between -2 and 1, all in through here, our actual y values are calculated by squaring the x values, because between -2 and 1, we're on this parabola part. So what we would really need to do is continue this trend like this parabola trend, however far we need to. But the thing is that it would stop when we get to where x is -2 and x is 1. So what we'll do then is we'll fill in what happens when we go all the way to -2 with x. Y would be 4. Or if we go all the way to 1 with x, y would be 1. So here's what that graph would look like. Now again, we'll have an arrowhead here because x is going to continue in that direction according to this part of the piecewise defined function. We'll have to have an open hole here because we are not actually including -2 for x in this part of the function. It's actually included here, so we have a filled in dot here. And we don't violate the definition of a function, because if we drop a vertical line through here, we're only going to hit the function one time right here. We don't actually hit it through here because we have an open hole. Now to the right here, we have an open hole on the end of the parabola, but that hole gets filled in because it joins up with this part of the piecewise defined function. Because where x is greater than or equal to 1, y is -x plus 2, and the actual function value at x equals 1 is 1 there. So we would fill in that dot because it joins up with this part of the function. And again, we have an arrowhead here. So here we are. We have our piecewise defined function defined all together again. Again, we have an arrowhead here, open hole here, filled in dot here, and filled in here because of the existence of the function here, and then an arrowhead here.